In this video, we're going to go through a transformations quiz review for a pre-calculus level class. So you might want to pause the video, try some of these problems on your own, and then check your answers with what we're going to do here. There's 10 questions, but they have multiple parts. So you can think of each part as like a point, and you could kind of grade this at the end if you'd like to kind of see where you're at. So let's dive into this first group of questions. The first thing you want to do is you want to name the parent function, okay, f of x. Then you want to describe the order of transformations. Okay, make sure you do them in order, that's important. And then part 3 is you want to write the equation of the new function, g of x. So what would you go ahead and do on for 1, 2, and 3? Go ahead and pause the video, try those. For number 1, I notice that this is the absolute value graph, okay, that V-shaped graph, and I know that the equation is f of x is equal to the absolute value of x. Now, if I was going to describe the order of transformations, one thing that I notice here is that when you graph the absolute value graphs, normally it's like has like a slope kind of like 1, like rise 1, run 1. Here you can see we're going up 2 over 1. So that tells us that there's a vertical stretch by a factor of 2. In addition to that, we can see that we're shifting right 3 and up 1. So if I was describing it, I would say vertical stretch by a factor of 2. Then I would say translate or shift right 3, and then translate up 1. So that's the order. Now, is there another possibility? Yeah, you could say vertical stretch by a factor of 2, then translate up 1, and then translate right 3. You get the same graph, and that's also correct. What you wouldn't want to do is say translate up 1 and then do a vertical stretch by 2, because it wouldn't yield the same graph. And you can see that by following that order of transformations. Now for the last step, part C, how do we write an equation of this graph? Well, g of x is going to equal 2 absolute value of x minus 3 plus 1. So that's our final equation for this one. Okay, let's go on to number 2 now. What's the parent function? Well, we can see that this is more of a U-shaped graph. This is a parabola, or what we refer to as a quadratic function. So for part A, let's say quadratic. And as far as the order of transformations, normally the graph looks like this, where the vertex is at the origin, it's opening up. But you can see it's being reflected, okay, over the x-axis. So let's start off with saying reflect over the x-axis. And then you can see it's not really being stretched at all, because normally with the parent function, it looks something like this, where you're going right 1, up 1, like that. Here we're just going right 1, down 1. So that's just a reflection. There's not a vertical stretch or shrink, but you can see that it's being shifted left 1 and down 2. So let's say translate or shift left 1 and then translate down 2. And is there another possibility? Well, you could say reflect, translate down 2 and then left 1. That would be correct. What you wouldn't want to do is say translate down 2 and then reflect. That's not going to yield the same graph. So be careful. The order of operations here, or the order of transformations, is important. And then for the last part, how do we write this equation? Well, this is going to look like g of x is equal to negative x plus 1 squared minus 2. Remember, whatever's grouped with the x has like the opposite effect on the graph, right? So the plus 1 is actually going to shift it left 1. When it's not grouped with the x, it's affecting the y values. So this minus 2 indeed will shift it down 2. And then again, notice this negative is not grouped with the x. It's making all the y values the opposite, which is reflecting over the x-axis. So that'll be your final equation for number 2 here. Now for number 3, what's the parent function for this one? This one, we would say f of x is equal to the square root of x. That's our radical function, right? Excuse me. And then for letter B, what is the order of transformations? Well, normally the graph would look something like this. But you can see it's reflecting over the y-axis. And I think that's, and then what it's doing when it reflects over the y-axis, then we're shifting to the right 4. So let's write that down. Reflect over the y Then we'll say shift right 4. And let's see if we're going to write the final equation now. That's going to look like this. G of x, our new equation, our new function, is equal to the square root of, let's see here, it's going to be, now let's see, is there more than one option here? Let's see, so we're reflecting over the y-axis, followed by shifting right 4. So that's going to look like this. So what's interesting is, if you were to distribute this negative, you could write this as negative x plus 4, which means that you would then be shifting the graph left 4 and then reflecting over the y-axis. That would yield the same graph. So you have a couple of different options, but you wouldn't want to say shift right 4 and then reflect over the y-axis. That would give you a different graph, and you can test that out and see for yourself. But I'm going to leave it for like this one. And that's the order of transformations. So let me erase the whiteboard. Let's get into some of the other examples. Okay, for this next group of 3 problems, what I'd like for you to do is, given the equation or the function, describe the order of transformations and then graph the final graph. So how would you do that for number 4, 5, and 6? Go ahead and pause the video, see if you can do these ones. Now, if I was going to do number 4 now, what I would do is I'd say, well, the order of transformations, you've got a few different options, okay? The main thing you want to be careful of with these problems is you want to do the vertical translation up or down last. That's one of the biggest mistakes students make. So in this case, I want to make sure I do this last. I could do, okay, one option is I could say shift left 2, reflect over the x-axis, vertical shrink by a factor of 1/2, then shift down 3. That's one option. Or I could say vertical shrink by a factor of 1/2, reflect over the x-axis, shift left 2, then shift down 3. So there's, different ways to do it and get the same result. But again, what you don't want to do is say shift down 3 and then do a vertical shrink by 1/2. You're going to get a different graph. Okay, so let's go ahead and make a table. Now the parent function is just this function here, y equals absolute value of x. And if I make a table, pick some easy numbers like -2, -1, 0, 1, and 2. The absolute value always makes the output positive, right? And let's just go and say reflect over the x-axis. Now remember, if it's not grouped with the x, okay, like not in the absolute value or not grouped with the x, it's making all the y values the opposite. So that's going to make this negative, negative, 0 is still going to be 0, okay, like that. Vertical shrink by a factor of 1/2, again, not grouped with the x, so it's affecting the y values. I'm multiplying all the y values by 1/2. This is going to give us -1, this is going to give us 0, this is going to give us -1/2 and -1/2. The plus 2 is going to shift left 2. Remember, when it's grouped with the x, it's affecting the x or horizontal direction, has the opposite effect. So plus 2, we're actually going to subtract 2. We're going to the left 2. Cross out these old numbers. And then lastly, -3, it's not grouped with the x. That means it's going to affect the y values in the same way as you would think, -3 down 3. So I'm going to subtract 3 from all these y values here. Cross out the old ones. Okay, now we have our points. Let's go ahead and graph. So -4 would put us right about here. Okay. And -3, -3.5 would put us right about here. -2, -3 puts us right about here. And then of course it's symmetric. Okay, and 0, -4 would be right about here. Okay, so there's your absolute value graph. Okay, and you got it. So for number 5 now, what did you get for this one? Describe the order of transformations, then get a sketch of the graph. Well, okay, now this is interesting. When it's grouped, first of all, the parent function you can see is x cubed. Let's just write that down, y equals x cubed. But when it's grouped with the x like this, we said it affects the x values, the horizontal direction. We also said it has the opposite effect. And what's interesting is that you can almost think of it as the reverse of the PEMDAS. So you'd say, do I do this multiplying by 1/2 first or this subtracting 1? Well, normally multiplying comes before, subtraction in the order of operations. It's actually going to be the reverse. You're going to shift right 1 first, then you're going to do a horizontal stretch by a factor of 2. See, it's the reciprocal. When it's grouped with the x, has like the opposite effect. If it's 1/2, you're multiplying by 2. If it was 2, you'd be multiplying by 1/2. And it's affecting the x values left and right, but just remember, it's like the opposite. So let's go through that again. So if I was going to describe it, I would say right 1, translate right 1, horizontal stretch by a factor of 2. But what are the values we're working with? Well, let's look at -1, 0, and 1. When I cube -1, I get -1. When I cube 0, I get 0. And when I cube 1, I get 1. So those are kind of like our key points. If I shift right 1, that means I'm adding 1 to all these x coordinates. The 1/2 is actually multiplying the x's by 2. That's a horizontal stretch. And now we've got our points. So let's see if we can graph this. So 0, -1 would be right here. 2, 0 would be right here. 4, 1 would be right here. Okay, so our graph looks something like this. Okay, there's our y equals x cubed graph. Okay, and you got it. So let's go to number 6 now. What did you get for the order of transformations for this one? Well, I can see it's a quadratic. See that x squared there. But the question is what is the order? Now, when it's grouped with the x like this, see this whole thing here? This is all, in my mind, grouped with the x. Okay, this is not grouped with the x, not grouped with the x. If it's not grouped with the x, it's affecting the vertical direction, the y values. If it's grouped with the x, it's affecting the horizontal direction, the x direction. But when it's grouped with the x, remember, it's like the Twilight Zone. It's like everything is opposite, right? Order of operations here is opposite. You know, the effect on the graph is the opposite. You want to think it's the opposite. So normally I would think parentheses comes before this multiplication by the -1. But when it's grouped like this, I do the reverse. I'm going to say the negative is actually going to make all the x values the opposite. So I'm going to say it's going to reflect over the y-axis. Then it's going to be shifting left 4. Remember, +4 actually shifts the graph left 4. Remember, adding and subtracting is a shift. Multiplying and dividing is going to be like a stretch or a shrink, you know, depending on the values. Then I would say vertical stretch by a factor of 3 and up 2 last. Remember, this vertical shift up or down is always going to be your last transformation. Now, you might be saying, Mario, is there another way I could do this? Well, you could say vertical stretch by a factor of 3 first, and then reflect over the y-axis, and then shift left 4, and then shift up 2. That would also give you the same graph. So let's go ahead and see if we can look at just our basic points here. Y equals x squared. Okay, so some key points here would be what? -2, -1, 0, 1, and 2. When we square those, we're going to get 4, 1, 0, 1, and 4. If I start here and I say, well, okay, I have to do the reflection first, then I'm going to shift left 4. Okay, so reflect over the y-axis makes all the x values the opposite. When I shift left 4, that means I'm subtracting 4 from the x values. Cross out the old ones. Vertical stretch by a factor of 3 multiplies all the y values by 3. Cross out the old ones. Shifting up 2 adds 2 to the y coordinates, right? Okay, now what's interesting is some of these points are going to go off our graph a little bit. So let me just kind of work with these ones right here. I think these are going to be a little bit easier to graph. So we've got -3, 5, which would put us, let's see, right about here, okay. -4, 2 is going to put us right about here. And -5, 5 is going to put us right about here. Okay, so you can see there's our quadratic function, our parabola, and you got it. So let me erase the whiteboard. Let's get into our next group of problems. Okay, for this next group of 3 problems, what we're going to do is we're going to take the parent function. We're given the order of transformations, 1, 2, 3, do them in that order, and write the new equation, g of x. So go ahead and pause the video, see if you can do these 3, and then we'll go through them. Okay, for number 7 now, we've got the absolute value function. We want to shift left 3. Okay, so when we shift left 3, all that's really going to look like now is x plus 3. Now group with the x because it affects the x direction, but in the opposite way. So that's going to shift left 3. Now reflecting over the x-axis, that makes all the y values the opposite. When it affects the y, it's not going to be grouped with the x, so it's going to be on the outside here. And then shifting down 5 last, that's going to be affecting the y's as well. It's not grouped with the x, it's going to be on the outside, that's going to be -5. So this is going to be our final result here, g of x. Now you can do this in another way, and I'll show you that on some of these other examples where you use the function notation, like you would say, okay, let me start with the h of x instead of g of x. Let's just say we have h of x equals f of x plus 3. So this would represent, I'm shifting the graph left 3. The way functions work is whatever's in parentheses goes in place of x here. So now you would say, okay, h of x is equal to the absolute value of x plus 3. Okay. Then you might say, how about m of x? Okay. M of x, now we want to reflect over the x-axis. What reflects over the x-axis? That's going to be negative 1 times h of x. But what's h of x? That's this whole function here. So that's negative absolute value of x plus 3. So that's our m of x. Then we finally get to g of x, okay, which is our final function. We're shifting down 5. We take this previous function, m of x, we subtract 5. But what's m of x? That's this whole thing here. So we're taking that whole thing, subtracting 5. That's going to give us g of x. So that's one way to do it. If there's a lot of steps involved, you want to make sure you get the, get it correct. Let's look at number 8. So we're taking our square root function, we're shifting right 2. So that one, I know that one right off the bat. That's just going to be x minus 2. Group with the x, it's affecting the x direction. It's the opposite. Minus 2 actually goes positive 2 to the right. If it was plus 2, it would go left 2. Now, when we reflect over the y-axis, let's just call this h of x for a moment. So let's say we reflect over the y-axis, we'll call this L of x. That's really going to be h of negative x. So we're taking this previous function, we're replacing x with negative x. Remember, if all the x values are the opposite, that's going to reflect the graph over the y-axis. So this is going to look like now square root of negative x minus 2. That's our L of x. Lastly, we want to shift up 1. That's going to be our g of x. We take the previous function, L of x, and we add 1. Now notice it's not group of the x. That's going to affect the y values in the same way. But what's L of x? That's this right here. So we can put that in place of L of x. And now we have our final function here, g of x. And then for the last one, number 9, we're starting with x cubed. And we want to shift down 4, vertical shrink by a factor of 1/2, then a horizontal shrink by 1/3. So for this one, shifting down 4, let's just say that L of x equals f of x minus 4. Notice it's not group of the x. It's going to affect the y values. It's going to shift it down 4. But what's f of x? That's x cubed minus 4, right? Now we want to do a vertical shrink by a factor of 1/2. So let's say m of x equals 1/2 times L of x. So remember, the 1/2, it's not grouped with the x, so it's affecting the y values in the same way, multiplying everything by 1/2. But what's L of x? That's this whole quantity here. So we're really taking 1/2 times x cubed minus 4. If I distribute, we're getting 1/2 x cubed minus 2. Okay, that's interesting. And then now what are we doing? We're doing a horizontal shrink by 1/3. So g of x equals m of 3x. Why 3x? Well, remember, when it's grouped with the x, it has the opposite effect. You're actually going to be dividing the x's by 3, or you can think of it as multiplying them by 1/3. And when it's grouped with the x, it's acting on the horizontal direction or the x direction. But the way functions work is whatever's in parentheses, that's going to go in for x on the right here. So we've got 1/2 the quantity, 3x cubed, minus 2 is our final function, g of x. So let me erase the whiteboard and we're going to do another example. Okay, before we do this last example, if a lot of this has been going over your head or you've been missing some of the problems, I'll put a link at the end to a transformations playlist that I did where you can kind of look at some of the different types of problems that we talked about in this quiz review. If you need more practice, check those out. And then if you've enjoyed this lesson, I have more quiz reviews on my Mario Math Tutoring YouTube channel if you're interested in quiz and test reviews. And if you want to go deeper, join as a channel member at the additional videos level, and you can have access to my math courses like my Algebra 1, Algebra 2, Geometry, Precalculus, as well as midterm and final exam reviews, ACT, SAT prep videos, and more. So almost 400 videos on that additional videos membership section at the additional videos level. So check that out, become a member, whether for a month, you can join, you can cancel, rejoin later if you want to jump back in, or if you want to join for 6 months, whatever works best for you. It's very flexible. Check that out. Okay, for number 10 now, we're given this function here, y equals f of x. We're going to transform it and graph the new graph over here using this transformation. So how do you do that? Go ahead and pause the video. What would the new graph look like? F of negative 2x minus 1. How would you graph that? Well, we can see I've got a table of some key points here on our graph. Okay, so what does this do to the graph? Well, the negative is going to take all the x values and make them the opposite. That's going to reflect it over the y-axis. So that means this is going to be positive 6, positive 3, 0, and negative 3. The 2, it's group of the x. It's going to affect the horizontal direction, but it's going to have the reciprocal effect. It's going to multiply the x's by a half. It's a horizontal shrink by a factor of a half. And then lastly, this minus 1, it's not group of the x. It's affecting the y values. It's going to have the same effect. It's going to shift down 1. So let's just subtract 1 from each of these y values. So now we have our key points. Let's see if we can graph this. 3, 1 would be right here. 1.51 is going to be right here. 0, 0 is right here. Negative 1.5, negative 1 is right here. Okay, so this graph would look something like this now. Let's see if that makes sense. So we reflected it over, we shrunk it horizontally by a factor of a half, and then we shifted it down 1. So, okay, perfect, you got it. So great job if you're able to follow these videos. Good luck on your transformations quiz or test. Again, I'll put a link to another video if you want more practice on transformations. Check out that playlist. Some of the key problems we talked about here are in those videos. I'll see you over in that playlist.